This is the second part of the dimensional analysis video. The first part we left off with the second example problem, so we'll pick up here with number 3. We're asked, you want to buy a car that costs $4,870. If you work 22.3 hours every week and make $9.55 per hour, how many weeks will it take you to buy the car? So we're very clearly asked for how many weeks. I'm going to start with that. Question mark, weeks equals, and then we're given several pieces of information here. Just kind of working our way through it. And every time I read the piece of information, I'm going to ask myself, is that a conversion factor, or can I use it as a conversion factor? If the answer is yes, then I'm going to jot it down as an equality. So first of all, you want to buy a car that costs $4,870. You could write one car equals $4,870. That would be one way you can write it. I'll go ahead and jot that down here. $4,870 equals one car. That would be one way to look at it. If you work 22.3 hours every week, there is another conversion factor. 22.3 hours equals 1 week. And make $9.55 per hour, there would be another conversion factor. $9.55 equals 1 hour. How many weeks will it take you to buy the car? Well, I know that we're going to buy one car. That we're not going to buy any more than that. So I'm simply going to start my conversion factor here with that $4,870. Oh, I left out the 8. Try that again. $4,870. From here, I can look at what I have given for my conversion factors to figure out how to get to weeks. Well, the only conversion factor that has money in it is my hourly wage, so I'll use that. I can see dollars need to cancel, so I'll put the $9.55 in the denominator, and I'll put 1 hour on top. Dollars cancel. Now I can see I can use my hours per week conversion factor in 22.3 hours, or that is the average number of hours I work in a week. So hours cancel, and you can see I'm now left in weeks, which is exactly what we were looking for. So at this point, we just need to plug it into our calculator. We have 4,870 divided by 955 divided by 22.3. So that gives me, let's see, 22.868. As far as Sig Figs here, your hours per week, that would have to be measured. So that's 3 Sig Figs, so I would need 3 Sig Figs here. So 22.9 weeks is what it would take us to buy the car. Alright, these next 4 here all deal with converting with Si prefixes, and we'll look at an easy way to do that. So the first question we have, how many meters are in 2.8 times 10 to the third kilometers? So question mark meters equals 2.8 times 10 to the third kilometers. Anytime we convert with SI prefixes, where the only thing that changes is the prefix, or we go from prefix to meters, which doesn't have a prefix, we can always do this in one conversion factor. And here's how we can do that. First of all, we need to recognize what each of the prefixes mean. Kilo is 10 to the third. The meter doesn't have a prefix, so I'll just put a dash there. That would be 10 to the 0, or 1. And then I'll ask myself, how many powers of 10 separate these two units? Well, between 10 to the 0 and 10 to the third, that would be 3 powers of 10. The next thing I'll ask myself is, which one of these is the smaller unit, meters or kilometers? Well, meters is a smaller unit, so that tells me that 10 to the third goes with the meters. There are 10 to the third meters in 1 kilometer. Here is my conversion factor. I can see that the kilometers needs to go in the denominator to cancel. So kilometers on bottom, 10 to the third meters on top. Kilometers will cancel. We're left in meters, and we're done. As far as getting an answer here, when it's in scientific notation like this, it's very easy. 10 to the third times 10 to the third, as we know, would be 10 to the 6th. You just add the exponents. So our answer is 2.8 times 10 to the 6th meters. Similar story here on number 5. We're asked how many liters are in 28 28.5 microliters. So again, I'll ask myself, what do these prefixes mean? Micro, as we know, is 10 to the negative 6th, and there is no prefix in front of liter, so that's 10 to the 0. How many powers of 10 separate the two? There are 6 powers of 10 between them. Notice it's not negative 6, there are 6 powers of 10 between 10 to the negative 6th and 10 to the 0. Which unit's the smaller unit? Well, that's the microliter, so that tells me there are 10 to the 6th microliters equal to 1 liter. And there's my conversion factor. There are 10 to the 6 microliters in every liter. Microliters cancel. And again, we've done the problem. I just need to get an answer. Now again, the scientific notation works well. Now the 28.5 is not in scientific notation, but if it were, that would be 2.85 times 10 to the first. Just move the decimal over one spot. So 10 to the first divided by 10 to the 6th, that's 10 to the negative 5th. So my answer is 2.85 times 10 to the negative 5th liters. Alright, the next two are slightly different in the fact that both of the units that we're dealing with have prefixes on them. So number 6, how many megaamperes or megaamps are in 3.6 times 10 to the 11th nanoamps? Now, question mark, how many megaamps be equal to 3.6 times 10 to the 11th nanoamps? Alright, same process. I'll ask myself, what do each of these prefixes mean? Mega is 10 to the 6th. Nano is 10 to the negative 9th. There are 15 powers of 10 between those two units. Next question, which one is the smaller unit? Well, that would be the nanoamps. We can see nano is a much smaller prefix, so that means there are 10 to the 15th nanoamps equal to 1 megaamp. And now I can use that as a conversion factor. 10 to the 15th nanoamps would go on bottom, 1 megaamp on top. Nanoamps cancel. I have 10 to the 11th divided by 10 to the 15th. That would be 10 to the negative 4th. So my answer is 3.6 times 10 to the negative 4th megaamps. Alright, last one. How many nanoseconds are in 275 centiseconds? Again, question mark, nanoseconds equals 275 centiseconds. Nano, as we said before, is 10 to the negative 9th. Centi is 10 to the negative 2nd. So there are 7 powers of 10 between those two units. The nanoamps is the smaller unit, so there are, nanoseconds. So there are 10 to the 7th nanoseconds in 1 centisecond. So I can do my conversion here. Centiseconds, 1 centisecond on bottom, 10 to the 7th nanoseconds on top. Centiseconds cancel. Again, thinking of the first number in scientific notation, that would be 2.75 times 10 to the 2nd. So 10 to the 2nd times 10 to the 7th is 10 to the 9th. So 2.75 times 10 to the 9th nanoseconds. And we're done with that part. Okay, number 8 was on the first video. I just copied this sheet off again. That's why you don't see those done. So we're going to skip over to the practice problems now on the back page. Alright, practice problem number 1. Just go ahead and read that to yourself there. So we're asked to find our speed in meters per second. So question mark meters per second is equal to 73.4 miles per hour. Notice how I've written this miles per hour. I explicitly show the hours in the denominator. Once we do the conversion, I'll show you why we want to do it explicitly like this, and some of the mistakes I'll see students make as far as not writing like this, and why that can lead to issues down the road. So this is the first time that we've seen a conversion where we've had to convert two different units. In this problem, we have to convert miles to meters, and we have to convert hours to seconds. Nothing changes as far as what we do. We just do one at a time. Once we finish one of them, we'll do the other one. So let's convert miles to meters first. As we discussed in the first video, this is a conversion where we're going from English length to metric unit of length. We always have to use this conversion factor, 2.54 centimeters equals 1 inch, to do that. So I have to convert my miles to inches, and then I can go over to the metric side. Well, you also might remember from before that 5,280 feet equals 1 mile. So I'll use that as a conversion factor here. In 1 mile, there are 5,280 feet. Miles cancel. Now to get to inches, we can use the familiar 12 inches per foot conversion. Again, feet cancel. Now I can use my centimeters to inches conversion. In 1 inch on bottom, there are 2.54 centimeters. Inches cancel. And then thinking about what we just saw with the metric conversions, we would determine that there are 100 centimeters, or 10 to the second centimeters, in a meter. So notice we've done the meters conversion. In fact, I'm going to go and circle it here and circle it at the beginning to remind myself I'm done with that part. So now if I stopped here and did this calculation, my units would be meters per hour. But we want meters per second. So we have to convert from hours to seconds. I'll just tack that on here at the end. Well, I know that there are 60 minutes in an hour. Notice here that the minutes go in the denominator, an hour in the numerator, so we can cancel with that original hours here at the start. And then we know that there are 60 seconds in every minute. And minutes will cancel. And we're done with the problem, because notice now we have seconds in the denominator, which is exactly what we want, meters per second, meters per second. So now it's just a matter of plugging this into our calculator. Here is a common error that I will find, students simply not plugging this into your calculator correctly. What you're going to hit here, or at least what I would hit, would be 73.4 times 5,280 times 12 times 2.54 divided by 100, because it's in the denominator, divided by 60, again because it's in the denominator, divided by 60. And that should give you the correct answer. My calculator tells me 32.813. The only measured value here is this first measurement of miles per hour. All these conversion factors are all defined equalities. They're not measured, so there's infinite sig figs. So I get to keep 3 sig figs. This would be 32.8 meters per second. Now I told you when we started the problem that I had explained why we want to write this original unit like this. A common thing that I'll see students try to do is try to write it like this, 73.4 miles per hour, just like so, and then start their conversion factors like this and start plugging stuff in. The problem is they don't recognize that hours is actually in the denominator. The way they have it written, it is still in the denominator. So when they get to these conversions over here to convert from hours to seconds, they treat it as if hours is in the numerator, and they get these conversion factors upside down. And this is why we want to write it like this. You see here at the beginning, explicitly showing that hours is in the denominator. Alright, 3 more to go here. So number 2 is the first time we've seen any problems with density. We're told the density of a sugar solution is 1.013 grams per milliliter. That is a conversion factor. What that tells us is that for every 1.013 grams of solution, there is going to be 1 milliliter of solution. I'm using the abbreviation SOL''N for solution. We're also told that the solution contains 25 grams of sugar for every 100 grams of solution. That would be another conversion factor. 25.0 grams of sugar are equal to 100.0 grams of solution. We're asked to determine the volume of a solution that would contain 500 grams of sugar. So what volume, think about what units that would be. Sounds like milliliters to me. So question mark milliliters of solution are equal to 500.0 grams of sugar. So looking at our conversion factors here, the only one that contains grams of sugar is this second one that I've written here. So I will use that as a conversion factor. 25.0 grams of sugar in the denominator, and 100.0 grams of solution in the numerator. Grams of sugar cancel, not grams of solution. Now if I look at my second conversion factor, I can convert from grams of solution to milliliters of solution, which is exactly what we want here. I can see I need grams of solution on bottom, so 1.013 grams of solution in every every 1 milliliter of solution, and grams of solution cancel. Alright, so you can plug this in your calculator here. We have 500 times 100 divided by 25 divided by 1.013. My calculator tells me 1,974.3. Now, as far as Sig Figs are concerned here, we have seen in the past where all the conversion factors were defined equalities. This is not the case here. Somebody had to measure out these amounts. They had to measure these when they were making the solution. So these conversion factors here, both the ratio of sugar to solution mass and the density, are measured. So this 25.0, that is only 3 Sig Figs. So I need to round this to 3 Sig Figs. Rounding that to 3 Sig Figs, that would be 1,970 milliliters of solution. And we're done with that one. Alright, question number 3. Go ahead and read that to yourself if you would. When I'm reading this, one thing I like to do from time to time, and you might find it helpful, and we could have done it up here above, especially on number 2, is to underline the conversion factors as I read them. We're told you drive your car with a speed of 58 miles per hour. That would be a conversion factor. 58 miles per 1 hour. You're told your car uses gasoline at a rate of 18.7 miles per gallon. That would be a conversion factor right there. And the gas costs $3.39 per gallon. That would be a conversion factor. And we need to determine how much you spend in gas driving for 92 minutes. So my answer, how much you spend, that's going to be dollars. So question mark dollars equals, I want to know how much I spend in 92 minutes. Notice 92 minutes is not a conversion factor. It's a single unit. A conversion factor by definition has to have 2 units, one for the numerator, one for the denominator. A good strategy, and lots of these, if you're not sure where to start with something that's not a conversion factor. That's a good way to do it. Now, if I'm starting in minutes, I know my conversion factor that I use first has to have time in it. But I notice the only conversion factor I have has hours in it, the miles per hour. So I need to convert my minutes to hours. There are 60 minutes in an hour. I've done that conversion. Minutes cancel. Now I can use my 58 miles per hour. In every hour, we drive our car 58 miles. Hours cancel. Okay, now I can use a conversion factor with miles in it. Well, I think that would be my fuel efficiency. My miles need to go on bottom. I get 18.7 miles for every gallon. Miles cancel. Lastly, I can use our price of gas to go from gallons to dollars. Every gallon costs us $3.39. Gallons cancel. And there we go. Now we just need to plug it into our calculator. So when I plug this in, I am going to hit 92 divided by 60 times 58 divided by 18.7 times $3.39. My calculator tells me 16.122. And thinking about Sig Figs here, everything here is measured with the exception of the 60 minutes in an hour. We're measuring the amount of time, our speed, the fuel efficiency, and the cost, in the sense that we have to measure the volume of gas we had. So I only get 2 Sig Figs here because the 92 minutes and the 58 miles per hour limit me to 2 Sig Figs. So this would be then $16 is what it would cost me. Alright, final one. This is the first time we've ever seen a percentage. We're told here the mass of a ring is 32.2% gold. Percentages can always be used as conversion factors. Here's what that conversion factor would be here. I'm just going to jot down a quick note about percentages. A percent literally means per 100. So when we see the mass is 32.2% gold, what that means is that 32.2 grams or kilograms or milligrams, could be any mass unit you want it to be. Okay, 32.2 grams of gold would be in every 100 grams of the ring. 32.2 grams of gold for 100 grams of the ring. That's what the percentage tells us. Alright, here are some other conversion factors here. We're told that the value of gold is $1,262 per ounce, and the ring has a mass of 35 grams. That would not be a conversion factor because that's just one unit there. 35 grams determine the value of the gold in the ring. So I need to find the cost. So question mark dollars equals, and again I'm looking for something that's not a conversion factor. Well, that would be my 35 gram ring. Notice that is the mass of the ring. 35.0 gram ring, not of the gold. This is why it's important to label what the substance is, not just with a unit. So I have grams as the unit, the substance or the object is the ring. I can use that percentage, the conversion factor we've written up here, as a conversion factor. I can see that for every 100 grams of the ring, 32.2 grams of that ring would be gold. Grams cancel. Grams of the ring cancel, I should say. I saw grams of gold there. Now we're given the cost or the value of the gold in dollars per ounce, so I need to convert ounces or I need to convert 2 ounces from grams. You can see that conversion factor is given to us right here. There are 28.3495 grams of gold per every ounce of gold. And now grams of gold cancel. Now I can use our value. There are $1,262 that I will get out of every ounce of gold, which that would be nice to have a bunch of gold because you would be very rich. Alright, so let's see what we get here. We have 35 times 32.2 divided by 100 divided by 28.3495, and then I need to multiply by 1,262. So this gives me a value of 501.69. Thinking about Sig Figs here, the measured values, grams, the mass of the ring would have to be measured, as would the percentage. Those are both 3 Sig Figs, so that'll limit me to 3. Both of those would have more than 3. So to 3 Sig Figs, my gold in my ring is worth $502. And that's the end of the video.